In this video, we are going to look into the evaluation metrics that we have got whenever we are working with the regression task. So let's have a look into this evaluation metrics. Now, the reason that we require this evaluation metrics because when we talk about any machine learning model that we would get after we perform the training, we want to measure as how exactly the model is actually working, because without measuring its performance, it's difficult to judge whether the model is performing better or whether the model is performing worse. So we have to find a correct way to evaluate the machine learning model so that we can ensure that the model gives us the output which is the generalized representation of the given inputs and the target data. Okay, we don't want to be in a situation where the model is performing well on the training data and not performing well on the test data. So we want to have a model which is a one which we call it as a best fit model for the given data set. In order to understand whether the model is performing best or whether the model is performing worse from the task perspective of regression, so we have got commonly used metrics. So let's understand each of it. So the evaluation metric that we commonly use is mean absolute error. This is the first evaluation metric. Now when we talk about this mean absolute error, here I'm going to consider my prediction and the target value. I will take the difference. While taking the difference, I'm going to ignore its negative sign. Then whatever the error that I'll get, that is the error which is a difference between the predicted and the expected output, I'll take the mean of that error. That will give me the mean absolute error. Okay, where it is sum of all the errors divided by total number of observations that we have got on the data set. Let me write this down here as a notes so that you can refer to it during your interview preparation. So it is the sum of all the errors divided by the number of observations. Okay, this is called as a mean absolute error. And apart from this mean absolute error, we have something called as mean squared error. So in the case of mean squared error, so this mean squared error, I would say it's one of the most widely used metric whenever we are working with the regression algorithm. So what it does is, this is going to find the squared difference between actual and the predicted value. So this will find the difference between actual and the predicted value, which is the square difference. So hence we call it as the mean squared error value. Okay, so this is number 2. And apart from that, we also have another metric that we commonly use, that is called as root mean squared error. So this is called as the root mean squared error. So root mean squared error is known as RMSE. Mean squared error is actually MSE. Okay, in case of root mean squared error, so as the name clearly says, it is the squared root of mean squared error. That's what we call it as a root mean squared error. And lastly, the most common one is the R squared or the R2 score. R squared or the R2 score is another metric that we use it to find how exactly my model is performing. Apart from that, the other metrics would include root mean squared log error. Okay, this is one metric that we have got, and we have something called as adjusted R squared. Okay, this is another metric. So these are the commonly used evaluation metrics in case of the regression task. So let us understand about the mean absolute error and how it is used to represent the performance of a machine learning algorithm. So in order to demonstrate the same, let me bring up my Excel sheet and we'll take up some example data set. I'll have my white row. Okay, so I'll say 20, 30, 25, 45, 33 and 41. So these are my true values, and I'll say ypred. These are all the predicted values. So the predicted values are given by, I'll say 28, 29, okay, I'll say 50, 52, 39, okay, I'll have some values something like this. These are all the predicted values from my, let us take the example of linear regression algorithm. Now obviously if you compare y true value and the ypred value, both values are not the same, isn't it? That means there is a difference between the expected value and the value that I'm seeing as an output. So in this case, we want to quantify the relationship, how much difference that I have got. So the general way to quantify what is the error that we have got, that is given by the difference. So error is given by y true minus ypred. So y true is nothing but the given value from the target, and ypred is the predicted value from the output. Now when I'm calculating the error, what I'll do is I'm going to ignore the negative sign. So if I ignore the negative sign, which is nothing but the absolute difference between this value minus this value, if I take the absolute difference between them, this is actually called as the mean absolute error. This column now containing the mean absolute error. Currently I have got only absolute error, okay, absolute error, that is what I have got. If I take the mean of this error that I have got, so if I say a mean, so the mean is nothing but, I'll take the average of these values. So average of these values is given by 4.16, and this is actually my mean absolute error. So in this way I can calculate the mean absolute error. The other metric is mean squared error. So whatever the absolute value that I have got over here, I'll just perform the square. So multiplication with itself. Okay. So this, if I do take the square of each and every value, and if I take the average of those squares, so this is given by mean squared error. The mean squared error is 20.16. Lastly, we have got root mean squared error. So the root mean squared error is actually the square root of mean squared error. So it will be square root of 20.16, which is nothing but 4.49. So in this way, we can evaluate the output that I'm getting from my regression task, that is with the help of MAE, MSE and RMSE. Okay, so these are the three commonly used metrics in case of regression. So let's go back to the notebook and let's find these metrics with the help of the scikit-learn libraries function. So all these metrics that we have got is available inside this sklearn.metrics, and I would import as mean squared error, mean absolute error. Okay, so I'm going to import both the function. Next, so here in order to generate the prediction, I'm going to say ypred is equal to lr.predict, and I'll send in my test data. Now in order to calculate the mean absolute error, I'll just have to send in my ytest as well as my ypred, and in this case the mean absolute error is 1.511, and mean squared error, if I calculate it, the mean squared error is 3.79. And if I want to calculate the root mean squared error, I just have to say squared is equal to false. So this will help me to calculate the root mean squared error. Now the common question that the learners would have is, okay, which metric that I have to use whenever I'm implementing in a project or when I'm doing a regression task? Well, to answer that, we will make use of mean absolute error when we do not have any outliers in the data set. When we have any outliers, then we generally prefer to go with mean squared error. Okay, so or the root mean squared error. These are the metrics that we would generally use. Okay, so these are the three important metrics that we have learned as part of this session. Now in the next video, I'll talk about the other evaluation metrics, especially the R-squared value, R2 score, and we'll also look into the root mean squared log error and the other evaluation metrics whenever we are working with the regression task. So I'll see you next time. And for the complete source code, do check out the link that I have shared in the chat window. So you can also go to the website manifoldairlearning.in, click on courses, and there's a course called Machine Learning and Data Science series. You can click on this link, and over here you just have to log in, join for free, and you'll be able to access all the source code in that website. Thanks again for watching. I'll see you next time.